Good afternoon, everyone. My name is Thomas. We are specialists in how to reduce operational energy and carbon. We are not specialists in embodied carbon, but I wanted to thank Julie for inviting me to speak today because A, we care about reducing carbon full stop, and B, we've worked for 5 years now on a number of projects with Kirsten and the KLH team, and who are embodied carbon specialists. And on all those projects, we've tried to reduce both operational carbon and embodied carbon. And I'm 100% convinced that we should do both and that we should not oppose one to the other. So this is why I wanted to start with this analogy. I don't know if some of you remember this movie. It was called Crimson Tide. It's quite a good one. But anyway, the plot is Gene Hackman and Denzel Washington are fighting to control the nuclear submarine. And I think sometimes the debate in our circles feels a bit like that the embodied carbon and the operational carbon people want to fight for the control of the net zero carbon submarine because they think that it enables them to go further and quicker. And I think that's a big mistake. So I'll approach this issue with an operational energy hat on. So there's a quite growing and strong consensus that the recipe to achieve low operational carbon is something like this. So you need to predict energy use accurately throughout the design and during construction. You need to design in an efficient form, adopt a fabric-first approach, incorporate heat recovery ventilation and opening windows, reduce all forms of energy users, not only the regulated energy users, incorporate low carbon heat, renewable energy, and finally, but very importantly, have a strong quality assurance process throughout detailed design and construction and commissioning. So what are their impact on embodied carbon? I think you will agree with me that the first one and the last one don't have any impact whatsoever. They are necessary methodologies, no impact on embodied carbon. What about the 6 in the middle? So let's start with the efficient form. This is a school building we've worked on, and we've assessed the impact on space heating demand of various forms. From you've got the standard form in the middle, let's say. The one on the left is where the architect had taken some extra liberty with the expression of complexity. And the one to the right is a very simple form. And the space heating demand would be reduced by at least 15%. Some may say it's not much. I would say it's quite a decent effort, bearing in mind that it is the same specifications and that it would also reduce cost and complexity, because with the complexity of the form comes complexity of junctions, thermal bridges, etc. If we look at what it means in terms of form factor, you're changing the form factor from, which is the ratio between the external envelope to the floor area, between 1.6 and 1.1. Which is very significant. So, for example, between the poor form factor and the medium form factor, you've got 20% less envelope. And surely that's the single best thing we could do for embodied carbon. It's less materials, less structure, less foundations. So on our projects, and I know many other people do, we push for a better form factor, and we think everybody should do that. If we move on to the fabric first approach. So fabric first, what we mean by it is a well-insulated envelope, attention to thermal bridges, a very airtight envelope, and finally very efficient windows, ideally triple glazed. We took the example of a block of flats, about 60 flats, and we've applied the London plan specifications and what we know based on product and knowledge which is available today, how well we could improve that. And that's the bar chart you see with a very significant demand, reduced demand in terms of space heating. If we translate that into of carbon, this is what it means. Now, be careful with these figures because they depend on the heating system, that depends on which carbon factors you've been using. So this is one example, but the reduction in carbon is significant, between 20 and 25%, about 4 kilograms of CO2 per square meter per year. And it goes beyond carbon, of course. You're saving energy for the residents. If you use an electrical system, a gas system, you're saving on emissions and air quality. And if you use an electrical system, you're reducing peak demand, which is good for the grid. What does it mean in terms of embodied carbon? So thank you, Kirsten, for sharing this data with us. This is the embodied carbon side of the equation for the similar block of flats. And the first thing to note is that the dominating part of this bar chart is groundworks, substructure, frame, upper floors. That doesn't mean that the rest is not important, but let's remember that the gray elements at the bottom are really the key element. We've tried, so the data doesn't come from KLH. I say it because maybe it's an approximation, maybe there's some mistake in the assessment. Forgive me for this, but I wanted to try to compare this to the operational side. So it's tricky to do because, as Simon explained before, elements have different life expectancies, theoretical, practical, so you have to divide the number by different periods, but this is what we ended up with. And the colored elements in the bar chart are essentially the roof, the external walls, the windows, and they represent about 3.5 kilograms of CO2 per square meter. The other thing to note is, in an external wall, insulation represents quite a small proportion of the build-up. But anyway, based on this approximate assessment, we think that the penalty in terms of embodied carbon of going fabric first is there, but it's relatively minor at around 0.3. So I'm not saying it is 0.3. Again, it depends on your design. It depends on, this is a block of flat. You would change for an office. But even if these figures are 50% wrong, this gives you an idea of the order of magnitude. And I would like to go back to the external wall. When I hear people saying, oh, we shouldn't add more insulation because of the embodied carbon impact, I think we should be extremely careful with this. Firstly, because the embodied carbon impact depends on the material you use for the insulation. And secondly, because the other 90% of the bar chart is really where we should spend our time on. When you look at these different build-ups, which are all possible for a fabric-first approach, admittedly we prefer some to others, but they're all possible. I think having a debate around, having 40 mil of insulation in addition or not is missing the point compared to, what's the additional embodied carbon of the cladding. Let's move on. Heat recovery, ventilation, and openable windows. So going back to the school example, these are the three generally used ventilation systems in schools. So opening windows only, or what people wrongly call NVHR, which is just an individual fan with a mixing box, and MVHR. Again, we looked at the impact on operational energy of these three systems, and the clear winner is MVHR. Does it have an embodied carbon impact compared to natural ventilation? Yes, of course. But again, the order of magnitude is just, different. Another thing we need to do to reduce operational carbon is worry about all sources of energy use. So, for example, pushing for induction solutions in schools, which is not only more efficient from a cooking perspective, but reduces the ventilation requirements and therefore the heating requirements. Reducing hot water consumption to reduce hot water load, making sure that the sprinkler system is insulated, etc., etc. Again, I don't think that there's a huge embodied carbon impact in any of these. Low carbon heat, so this is a tricky one, and we have not attempted at quantifying it because it's too complex. So this diagram shows you the different types of heat pump systems you can have, for example. And there's so many of them, so many different scales of embodied carbon systems that it's quite difficult. I'm aware of 1 or 2 papers which have had a go at this, but we don't know that much. And anyway, the Committee on Climate Change is really clear that we need low carbon heat in our buildings. So, you know, what's the point in comparing a gas boiler to a heat pump if we know that gas boilers shouldn't be part of the future? Another big one is PVs. So I know there's an ongoing debate around PVs, and again, we at Etude strongly believe that PVs are great, they work well, they're better and better year after year. Of course, if you add a PV panel on your roof compared to no PV panel, there's an embodied carbon penalty, but let's take a step back. The embodied carbon penalty, so we've translated it into a grams per CO2 of CO2 per kilowatt hour for polycrystalline or monocrystalline panels. And at the moment, the figures on the left represent the current figure. And they're predicted to go down over time. But when we plot it against not the embodied carbon content of the grid, but just through the operational stuff, the figures from the National Grid future energy scenarios, PVs will always be under that value. So from a whole life carbon point of view, it will always make sense for the foreseeable future to have PVs on your building. So to finish the presentation, I wanted to emphasize that we have a lot in common. When you look at the buildings which have achieved a fantastic reduction in operational energy use, guess what? They're often buildings which have tried to achieve a very low embodied carbon. So that's a big thing we need to remember. The clear win-win is on the efficient form, and I don't deny that in the future more and more we need to look at the whole life carbon assessment, but let's bear in mind that we should spend our time on what matters. And going back to the nuclear submarine analogy, let's not forget that there's no enemy other than mitigating climate change. This is what we should have our eyes on. And so let's do both. Let's push down operational energy and let's push down embodied carbon. In 2030, based on what we know today, we think we can design buildings which will have very low emissions, and PVs can take them down even more. So we now know how to do it. Let's do it. On embodied carbon, I think it's probably a bit less. We're not there yet. So let's do our best to bring it down. I would strongly advocate to keep those separate, because if we merge them together now, we will make the whole picture less clear. But let's do both. So thank you.